Let's work on a technique for finding the coefficients of a binomial expansion more quickly. How could we go through all of these possible combinations, right? We're going to have patterns start to emerge when we're trying to expand something to the second power or the third power or the fourth power or the fifth power, etc. If a binomial was raised to the 0th power, you would have 0 choose 0 as the coefficient. If the binomial is raised to the first power, then we would have coefficients 1 choose 0 and 1 choose 1. If the binomial is raised to the second power, we would have coefficients 2 choose 0, and then you'd have 2 choose 1, and then you have 2 choose 2. A binomial raised to the third power would have these coefficients, and so on. Each line represents a different power of n that we've raised the binomial to. And so if we actually calculate each one of these coefficients, we end up getting a pyramid that looks like this. The numbers in this pyramid give us the coefficients for each expansion. So I've only gone to an exponent here or a power of 6, but we could keep building this pyramid further and further and further. And if you look closely at the pyramid, you'll start to notice some patterns. So the idea of having to find all of these combinations to build this pyramid is not actually necessary. This pyramid is known as Pascal's triangle. It has many patterns embedded within it. The first that we'll notice is that the outside of the pyramid is flanked in ones. And then the next level in the pyramid corresponds to the n value. So here we have a 2, and then a 3, a 4, 5, 6, 7, 8, etc. on both sides. The way we get the pattern here in the middle, the way we build the numbers in the middle, is to look at smaller triangles. So look at this 4 and this 6. Together they add to 10. Look at this 3 and this 1. Together they add to 4. This pattern is repeated throughout the entire triangle. So we can find any number by looking at the two numbers above and adding them together. Armed with that information, could you build the next row? Well, we know it's going to start with a 1, and it's the 7th row, so my next number is 7. And then to get the number after the 7, I need to look at the two numbers above and add them. 6 plus 15 is 21, and 15 plus 20 is 35. Pause the video and try building a few more rows on your own. Now you have a more efficient way of finding the coefficients in a binomial expansion problem.